Hi, welcome back to my channel. My name is Gina. Last week, we talked about the geometric optics. We looked at an example of lens and an example of mirror. We can also have a combination of lens and mirror. Let's look at this example. An object is midway between a concave mirror and a diverging lens, which are separated by a distance of 25 centimeters. The magnitude of the radius of curvature of the mirror is 20 centimeters, and the magnitude of the focal length of the lens is 16.7 centimeters. Consider only the light that leaves the object and heads toward the mirror. A. What is the location of the final image? And we are going to sketch it on the diagram. And B. What is the overall lateral magnification of the final image? Is it reduced or enlarged? Is it upright or inverted? Is it virtual or real? Let's start with part A. Find the final image. To find the final image, we need to consider two steps. First step is when the light is reflected off from the mirror. And the second step is the reflected light passes through the lens. And for the second step, we are going to use the image formed from the first step as the object. So in the first step, light is reflected off from the mirror. Since the object is in the midpoint of the mirror and the lens, and the separation distance is 25 centimeters. So S1, the object distance for the first step, is half of the distance, which is 12.5 centimeters. And the radius of curvature is given that the magnitude is 20 centimeters. And it is a concave mirror, so we have positive R. So R would be positive 20 centimeters. Then we use the mirror equation. 1 over the object distance plus 1 over the image distance equals to 2 over R. So S1 prime is the inverse of 2 over R minus 1 over S1. We substitute the numbers. Inverse of 2 over 20 centimeters minus 1 over 12.5, which equals to 50 centimeters. Now let's look at the second step. Second step is when the reflected light from the mirror, passes through the lens. From the first step, S1 prime is positive, which means the image will be on the same side as the outgoing light, and it will be 50 centimeters away from the mirror. So S1 prime will be around here. This distance is 50 centimeters. And we are going to treat the image formed from the first step as the object for the second step. So this is the S2, object distance for the second step. But now the object is on the opposite side as the incoming light, because the reflected light is passing through the lens from the left to the right. But the object, S2, is on the right. So here we have a negative S2, which means we have a virtual object. S2 would be the negative of the distance from S1 prime to the lens, which is this distance. This is 50 minus 25. The D. So S2 is negative 25 centimeters. How about the focal length? F2. Here we have a diverging lens, so F2 is negative. And magnitude is given from a problem, 16.7. Then let's use the thin lens equation. 1 over the object distance plus 1 over the image distance equals to 1 over f. Then we can solve for the image distance, S2 prime, which is inverse of 1 over f minus 1 over S2. We plug in the numbers. Inverse of 1 over negative 16.7 minus 1 over negative 25, and we get negative 50.3 centimeters. S2 prime is negative, which means the image formed from the lens will be on the opposite side as the outgoing light. So it will be on the left of the lens. And it is 50.3 centimeters away. So S2 prime will be around here. And this distance is 50.3 centimeters. Now let's look at part B. We want to find the total lateral magnification, N. When we have a combination of lens or mirrors, the total lateral magnification will be the product of the magnification from each lens or mirror. So M will be negative S1 prime divided by S1 times negative of S2 prime divided by S2. Then we substitute the numbers. S1 prime is positive 50 centimeters and S1 is 12.5. And S2 prime is negative 50.3 and S2 is negative 25. So we get the total lateral magnification is 8.05. It's positive, so the image will be upright, and the magnitude of M is greater than 1, which means the image will be enlarged. And S2 prime is negative, which means the image is a virtual image. And that is the end of the video. If you have any questions, feel free to comment below. And if you like my videos, please like and subscribe, and I'll see you in the next video.